Okay, let's dive right into this explainer. We're talking about how to completely transform your approach, going from a casual Googler into a highly systematic researcher who can easily navigate the vast sea of academic literature. Look, we all start with a basic idea, right? A research question, maybe a handful of keywords. But actually finding the right research? Well, it isn't just a matter of typing your topic into a search bar and hoarding the very first PDFs that pop up. Today we're going to break down how to search like a true professional.
To get there, we'll follow this roadmap. 1. The Google Scholar difference. 2. The Boolean search formula. 3. Filtering and expanding. And finally, 4. The search log system.
First up, Part 1, the Google Scholar difference. Let's start by breaking down that very first reflex you probably have, typing your entire topic as a full sentence into a standard search engine. I mean, it's exactly how we look for a new recipe or movie times, right? But a standard search is just pulling from everyday websites, blogs, and general online content. Google Scholar, on the other hand, is your dedicated discovery tool. It specifically targets journal articles, conference papers, theses, and books. It completely cuts through the internet noise to find the actual scholarly literature you need to build a credible foundation for your work.
But Scholar isn't the only tool you should be using. Since no single database contains every single paper ever published, that would be impossible, a truly good literature search requires you to explore specific major databases. So if you're doing robotics or electrical engineering, IEEE Explore is absolutely invaluable. Doing something in computing or IT, you'd want the ACM Digital Library. And then you have platforms like ScienceDirect and SpringerLink offering massive multidisciplinary archives, plus MDPI for open access content. Knowing exactly which database specializes in your field is literally half the battle won.
Moving on to Part 2, the Boolean search formula. Now, to get highly targeted results, we are going to start treating search strings like mathematical formulas rather than conversational sentences. This is exactly where you level up from a casual searcher to a precision researcher, using Boolean operators. Let's look at our first operator, AND. The crucial point here is that AND makes your search narrower. It forces the database to find only papers mentioning both concepts. So, if you search electric vehicle and battery, every single result returned must contain both terms, which instantly filters out a ton of irrelevant noise.
So let me ask you this. Which search is likely to produce fewer results? Just robotic manipulator or robotic manipulator and machine vision? Think about it for a second. Because AND narrows the field, that second option is going to give you a much more targeted, smaller set of results. The first search will just throw every paper on robotic manipulators ever written at you. The second search demands that the paper also discusses machine vision, filtering out literally everything else.
Now for the exact opposite, OR acts as your safety net. It expands your search, catching papers that might use slightly different terminology for the exact same concept. Authors use different words for the same things all the time, right? One might write out electric vehicle, while another just types EV. By linking them with OR, you are essentially telling the database, hey, I don't care which term the author used, just give me papers that have at least one of them.
Then you have NOT, which actively removes things from your results. But we really need to bust a myth right here. More complicated search strings aren't always better. And using NOT too aggressively, it might accidentally delete highly relevant papers. For example, say you search robot navigation, not medical. You might actually miss an incredible, groundbreaking paper on general robotic navigation simply because the author happened to mention the word medical just once in their conclusion as a potential future application. So use this one with extreme caution.
Before we put this all together into a master formula, let's look at one more simple but incredibly powerful tool, quotation marks. This is basically superglue for words, keeping multi-word concepts stuck together in the database's eyes. If you just type autonomous mobile robot without quotes, the database might find a paper where the word autonomous is on page 1 and the word robot is buried on page 10. But by wrapping the phrase in quotation marks, you force the database to look for that exact, specific string of words.
Okay, let's move to how this builds into a sophisticated formula. We do this by breaking our overall topic down into specific concept groups. We are not just throwing keywords at a wall hoping something sticks. We categorize them. So, we might have an application group, a problem group, and a technique group. And within each of these groups, we use our good friend OR to capture all our synonyms.
And here is the magic. By combining our separate groups with and keeping our synonyms linked with or inside parentheses, we've just built a highly professional, realistic search string. This specific string tells the database to find literature that tackles the application and the problem and the technique while remaining totally flexible on the specific vocabulary the authors decided to use. Honestly, this is the ultimate secret to highly effective, efficient literature searching.
All right, part 3, filtering and expanding.
Okay, so you've hit search. You've got your results. But before you panic and just download 100 PDFs straight to your desktop that you know you'll never actually read, let's filter. Just finding papers doesn't mean you've done a good search. You have to systematically check this evaluation list to confirm relevance. Read the title, skim the abstract and the keywords, and always check the publication year to ensure the technology isn't completely obsolete. Only after passing that test does a paper earn a coveted place in your downloads folder.
And here is a pro tip for your database filters. Don't fall into the trap of thinking you should only ever read the absolute newest papers. Older papers often contain the core foundational theories you absolutely need to understand. If you are totally new to a topic, sort your database results by relevance first to find those major foundational works. Once you deeply understand the basics and you really need to see the cutting edge, well then you can sort by date to see what was published just this year.
When you're evaluating those papers, you're almost always going to see a citation count. Now, it's absolutely vital to remember that a brilliant paper published just last month might have 0 citations, simply because it's brand new. High citations generally mean a paper is highly influential in its field, which is great, but a low citation count on a recent paper does not automatically mean it's low quality. So please don't use citations as your only metric for quality.
So, what happens when you find the perfect paper, but suddenly you hit a massive paywall? Never assume a paper is totally inaccessible just because the very first website asked for your credit card. Always work through these 5 bypass options. First, check your university or institution's subscriptions. Then look for an open access version. If that fails, copy and paste the exact title into Google Scholar to see if there's a free PDF hosted somewhere else. And finally, check the author's own university repositories. They are actually often legally allowed to host a preprint version of their work right there for free.
Once you finally have that one perfect, highly relevant paper in your hands, it's time to use citation chaining, which means searching both backwards and forwards to rapidly expand your literature web. You look backward by scanning their reference list to see what foundational research they built their ideas upon. Then, you use tools like Google Scholar to look forward, checking the Cited By link to see what new, exciting research has been published building off that exact paper since it was originally written. And finally, part 4. The search log system.
We have reached the final and honestly the most crucial habit that separates a professional researcher from an amateur, documenting the journey. Think about it. If you can't explain exactly how you arrived at your specific pile of literature, your research just isn't reproducible. Every single time you run a major search, you need to log the date, the database, the exact Boolean string, and the filters you applied. Document exactly what you kept and why. Trust me, this prevents you from running the exact same useless search 3 times on 3 different days.
To summarize everything we've covered today, success isn't about finding 500 random papers. It's about executing a focused, documented, and inclusive process. You're building targeted searches with and, you're capturing synonyms with or, you're tracking every step in a log, and most importantly, you are treating the whole thing as a continuous, iterative cycle.
I want to leave you with this final, provocative thought. Your very first search is never going to be your last. As you read your first few foundational papers, you are guaranteed to discover new keywords, new problems, and new techniques that you didn't even know existed yesterday. So the question is, how will you adapt these tools and evolve your search strings as your own research journey unfolds? Happy searching!